Okay, well, good afternoon, everybody, and welcome along to DBA Fundamentals Down Under for the month of February. My name's Warwick Rudd, and I'm your host once again. And for this month's session, we've got Glenn Berry from SQL Skills talking to us about migrating to SQL Server 2017. Now, I'll hand over to Glenn very shortly. I just do have a couple of slides of housekeeping to run through, and then Glenn will take us through the rest of the session this afternoon. So first off, I want to say a big thank you and call out to our sponsors, SentryOne. Without SentryOne being here and sponsoring us, it would be difficult for us to put on these sessions for you each month. If you're not already using SentryOne's tools, make sure you go to their website. They have some fantastic articles, downloads, videos, ebooks, etc., to assist you on your SQL Server learning. To let you know, this session is being recorded and will be available on the DBA Fundamentals archive site in a couple of days' time after this. We have the slides from today will be available, as well as one of the scripts that Glenn will be taking you through. Throughout the session, feel free to ask any questions. I will be monitoring those, and I'll hand those over to Glenn at the end of the session. Make sure you stay involved. Sign up for any of the other virtual chapters around, like this one, or your local chapters, SQL Saturday events, and of course, Pass Summit towards the end of the year. So with that, I'll hand over to Glenn, and we'll get this afternoon session running.
All right, thanks a lot. And thanks for everybody who showed up to listen to this. So let's see if we can get PowerPoint running here. Come on. So anyways, I'm Glenn Berry, and I work for SQLskills.com. And for some reason, PowerPoint is being uncooperative at the moment. So that's not good. Great.
Just bear with us, everybody, while we sort out the issue with PowerPoint. We should be on very shortly. So I've got some questions whether we're speaking. Can everybody just confirm that they can hear me at the moment? Just shoot through a question or an answer for me, please. Okay, thank you. If you just bear with us while we sort out the technical issue with PowerPoint, and then we should be able to get the session going. Do I have any good stories? What sort of stories would you like to tell?
All right, can you hear me?
We can.
All right. I don't know what happened there. My computer crashed, so sorry about that. So let's see if we can actually get started this time.
Okay.
All right, my name is Glenn Berry, and I work for SQLskills.com. And after that long delay there, we're going to go ahead and get started here. So can you see my screen, the PowerPoint?
Let me see if it has frozen this end. Let me just take the presenter screen back, and then I'll give it back to you, and hopefully that will refresh it.
Okay.
Okay, and giving it back to you.
All right, can you see that?
Yes, you can see your slide deck.
Okay. All right, here we go. All right, this is Migrating to SQL Server 2017. I'm Glenn Berry. I work as a principal consultant for SQLskills.com. And this is a little bit about me. The main thing to keep in mind here is that my email is glenn@sqlskills.com. If you have any questions that I don't answer, please send me an email and I'll definitely get back to you. And this is a little bit about me. I like to brew beer, and I have a 3-vessel stainless steel system that I use to make 5-gallon batches. And then there's a little bit of some of the beer that I've brewed recently. So getting to the business part of this, what we want to talk about is the agenda for this session. And so first is making the case for an upgrade, and then some important upgrade planning steps. And we'll talk just a little bit about hardware for SQL Server and how you choose your hardware to minimize your license costs. And we'll talk about some different migration methods you can use, and finally some post-migration tasks. So the first thing you want to do is make the case for an upgrade, because I've never had anybody come up to me in my career and say, hey, Glenn, would you like to upgrade to the next version of SQL Server? You know, usually as the DBA, you've got to go and make that case. And so you've got to gather all the evidence and make the argument to convince your business to make the move. And so some of the things you can do is finding out things like, is your version of SQL Server still supported by Microsoft? A lot of versions, including SQL Server 2012, have dropped out of mainstream support, and it may even be out of extended support. And if that's the case, you might be able to get premium assurance, but you might not be able to. Another thing to think about is whether your operating system is out of support or not. And also, is your hardware or storage out of warranty, or is it just really old and slow? Some key reasons to try to upgrade to SQL Server 2017. There's been a lot of useful new features that have been added since older versions that you might be running on right now. And there's a lot of new things that are in standard edition since SQL Server 2016 SP1 that used to be enterprise only that are actually really useful. And a couple new features in SQL Server 2017 that are extremely useful are automatic plan correction, which builds on top of Query Store, and adaptive query processing, which gives you better query plans in some cases than you got before. And these all came from Azure and they've gone into the on-premise product. You also get higher license limits for standard edition than you did on older versions of SQL Server. And you can take advantage of some of the new hardware and storage things that are available when you're running on SQL Server 2016 or newer. And again, the legacy version of SQL Server you're running might be out of support. Plus, you've got a lot of manageability enhancements in the latest version compared to old versions of SQL Server. So these are some of the key arguments you can try to use to make the case for an upgrade. Now, I've got a bunch of links here, and again, you're going to get this deck that's going to talk about some of the most important things that are new in SQL Server 2016 and 2017. So a lot of good links here that I don't have time to go through all the new features. And this is a useful slide because it shows you when SQL Server falls out of support for the different versions going all the way back to SQL Server 2005. So 2005 is out of mainstream support and extended support, and there's not even going to be a patch for the meltdown Spectre bug for 2005. And 2008 and 2008 R2 are also both out of support, but they have been patched for that security issue. And then SQL Server 2012 is out of mainstream support, but not extended. And then you can see the dates going out. And one thing that may take a lot of people by surprise is 2014 only has about a year and a half of support left before it goes out of mainstream support. So a lot of people are probably running on versions of SQL Server that are out of support from Microsoft. And what that means is there's no more service packs, no more cumulative updates, only security fixes once it falls out of support. So here's the same chart for Windows Server. And depending on how old your version of Windows Server is, you may be out of support there or coming up. And another one that's going to surprise some people is Windows Server 2012 and 2012 R2 are falling out of support in about 6 months. So that's coming up fairly soon. And 2016 has quite a while to go. And as you're going through this process, you want to take the time to do proper upgrade planning, and don't just leave this to your system admin and your network admin. You want to be involved as the DBA. And so some of the things you want to think about doing as you're going through this process is finding anything that's going to be an upgrade blocker or prevent you from actually upgrading to 2017. And in some cases, it's a problem with in-house code, the way it's been written, or maybe you're using third-party applications that aren't certified for SQL Server or a certain version. And Microsoft's notorious for that. For example, Dynamics GP won't run on some newer versions of SQL Server, depending on what version of Dynamics you have. So investigating that can be really important, from the beginning. And then you've got to make sure you understand the licensing differences between the versions and editions of SQL Server, and understanding the feature differences between the versions and editions of SQL Server. And if you know, for example, because of budget pressure, that you're going to be stuck on standard edition instead of enterprise edition, that's going to affect a lot of what you decide to do in terms of your architecture and what hardware you end up picking, and whether you get too big of a box for standard edition. And so, that ties into picking your hardware and storage based, again, whether you're going to be on standard edition or enterprise edition. And then one thing that's super important that I hope you take out of this talk is you want to pick the hardware to minimize your SQL Server licensing costs. Because if you're not careful about this and you just let somebody else do it who doesn't understand how this works, you can spend a huge amount of money on licenses far outweighing your hardware, and in some cases even your storage costs, just on your SQL Server licenses. And then you want to think about how you're going to do your final migration to reduce your downtime during that final production migration. So here's how much SQL Server 2017 costs, and there was no price increase over 2016. And in most cases, you're going to be doing core-based licensing. If you're going to use standard edition, you do have the option of a server license plus CALs, but you can't do that for enterprise edition. So you can see that these core licenses are pretty expensive for enterprise edition, although not nearly as expensive as Oracle. And so you need to think about what you're doing when you're picking out your hardware, so you don't end up spending a huge amount of extra money that you don't need to. And you have a minimum of 4 core licenses per physical processor or per VM, unless you decide to license the entire host for virtualization purposes. So SQL Server 2017 has license limits tied to what OS it's running on and whether or not you're running Enterprise Edition or Standard Edition. So if you are running SQL Server 2017 Enterprise Edition, you can use up to 24 terabytes of RAM on Windows Server 2016, which is a lot. There's very little commodity hardware that will support that much, but that was a big jump over what you could do on Windows Server 2012 R2, which is only 4 terabytes. And then you can use as many sockets and as many cores as you can get your hands on for Enterprise Edition. But the story is very different for Standard Edition. And this is very frustrating to me because these limits really haven't changed that much. In fact, they haven't changed at all over SQL Server 2016. And Standard Edition only supports 128 gigs of RAM for the database engine per instance. And then you're limited to the lesser of 4 sockets or 24 physical cores. And I've had a lot of my customers run into that issue sort of accidentally, where they install Standard Edition on a bigger machine than that, and then they find out that it's only using a small portion of their hardware. And that can be an issue that you don't want to run into. So Windows Server 2016 has some licensing changes you need to think about. It also uses core-based licensing, and luckily it's much less expensive, but the way it's set up is that they require you to buy a minimum of 8 core licenses per processor or 16 for the server, whichever is higher as a bare minimum. And so this sometimes drives your system admin or people who are picking the hardware into picking a machine that has more cores than you actually need for SQL Server, so they get their money's worth from their Windows Server licenses. And that's sort of backwards thinking, because Standard Edition of Windows Server 2016 only costs $882 for 16 core licenses, and that's just nothing compared to the SQL Server license costs. So you want to make sure that somebody's not picking a bigger machine than you need just because of this. SQL Server should be driving it, not Windows Server, when it comes to picking how many cores you need. All right, so the importance of database hardware. And normally when I do this session, it's either a half day or a full day. So I would spend a lot of time, probably more than you want to hear, talking about hardware, where you're going to get a very abbreviated version here. But database servers are mission critical. People tend to notice when there's problems with performance or scalability. And I can't tell you how many times I've heard, what's wrong with the database? Why is the server so slow? And it's always guilty until proven innocent. And if somebody makes a poor choice on your hardware, whether it's bare metal or a virtualization host, you're going to be stuck living with that for the lifetime of that server. And it can be really difficult to compensate for that if somebody's made a really poor hardware choice. So things like single-threaded CPU performance, if you don't have any memory or I/O bottlenecks, that's your ultimate bottleneck for how fast a query comes back. If you don't have enough memory, that's going to cause extra I/O pressure. And unfortunately, memory prices have been going up quite a bit over the last 12 to 18 months. And then not having enough I/O performance can be a huge bottleneck that I see a lot in real life. And if you know what you're doing, which you're going to know somewhat after this session, you can save so much on your SQL Server license costs that your hardware is free. And that's not an exaggeration. And you really need to pay attention to this so you don't make a huge, expensive mistake. So right now, the latest and greatest Intel processor line is called the XeonScalable processor family. And their code name is Skylake SP. And this chart right here in this slide, this is a super valuable chart, this one in the next slide. And this shows different processor models. They've changed their naming. So instead of like E5 and E7 like we had in previous generations, they have names like gold and bronze and platinum and then a model number. And this is showing different specific processor SKUs at given core counts. And this list is the list of the best processor at each given core count. So at the very bottom, it's a gold 5122 with 4 cores, and then some statistics including the cost of the processor. So you can go up 6 cores, 8 cores, 12 cores, and so on until you get to the top of the line 28 core. And for most SQL Server applications, the 28 core processor is not a good choice. because you're going to pay a huge amount for your SQL Server licenses. And typically you want to try to pick one with a lower core count. And so the reason I put this chart together is that for every core count, like 4, 6, or 8 cores, there's typically 2 or 3 or 4 different SKUs in that family. And of all the ones that are available, these ones in this list are the best ones for SQL Server. So if you or your sysadmin or your hosting provider wants to have a different processor that's not on their list, on this list, you're doing it wrong because you're not picking the best one at a given core count. And so this next slide is even more useful. It lists the same processors, but it shows the raw capacity of the system, and then the score per core is the second from the right column. And so the raw score, and this is based on some proprietary calculations I've done based on TPCE OLTP benchmark scores, but the raw TPCE score is the capacity of the system from a CPU perspective. And then the score per core is showing you the single threaded performance of that processor. And then the final column on the right is how much your SQL Server licenses would cost for a 2-socket system with this processor. So what's happening here is that the ones that are in green towards the bottom of the chart are really good choices for super high single-threaded performance. And then the one in red, the second one from the top, is a really terrible choice, for example. But these are both money slides because this helps you pick a good processor to minimize your SQL Server license costs and make sure you have enough capacity and performance for your workload. So moving on, here's an extreme example of a really bad CPU choice versus a much better CPU choice. So imagine you're going to go out and buy a brand new 2-socket server, and your sysadmin, without talking to you, goes out and decides to spec out the server and decide what they're going to buy. So they decide to get 2 8-core processors, and they decide to pick the Xeon Bronze 3106 because that's the least expensive one with 8 cores. And so if they did that, they would end up spending $114,000 on the SQL Server licenses, and their capacity, that TPCE score, would only be 640, and their score per physical core is their single-threaded performance, that would only be 40, and that's pretty bad. And so what you could do instead, if you knew what you were doing, is you could get that same 2-socket server and only get one processor in it that happens to be a 6-core instead of 8-core, but it runs at a much, much faster clock speed. It has turbo boost, it has hyper-threading, has a bigger L3 cache, and so it performs much, much better. So one 6-core processor versus 2 8-core processors, and you actually get more capacity and nearly 4 times better single-threaded performance and less than half the SQL Server license cost. So this is a very extreme example, but this shows the kind of mistake that somebody could make. You know, a well-meaning person who just doesn't understand how this works could make. So hopefully you will not make that kind of mistake. All right, so the Intel Xeon processor family, these links show you, these link to documents that they're about 4 to 5 pages each. And so depending on how old your current hardware is, you can go back in time and find out about it, and then go through the successive newer generations to find out what things have changed and what things have improved. And in many cases, virtualization performance improves as you go from older hardware to newer hardware. And so these have all sorts of details that are really useful when you're trying to make the case that, hey, we're running on 6-year-old Sandy Bridge processors, E5 2600. And if we move to the latest generation, here's all the new things we would get that would help us because we're virtualized, for example. That's what those documents are useful for. All right, so after the hardware, which I said was to be abbreviated, then you start thinking about, okay, what can I do to get my legacy SQL Server instance ready to migrate? And so the first thing you want to try to do is make sure that that legacy instance is on a supported service pack and CU of whatever version of SQL Server you're running. And ideally, it's on the latest and greatest service pack and CU. But there's certain minimum levels that are required depending on what you're going to do for migration. So for example, if you're going to do something like database mirroring from your old version to the new version, you need to be on a certain level of SQL Server. So I've got that listed here. So for example, on SQL Server 2012, you need to be on Service Pack 2 as a bare minimum. And if you're on older versions like SQL Server 2008 R2 or SQL Server 2008, you can see the service pack levels that are required there. And then after that, you want to go through and just sort of do some house cleaning on your legacy instance and try to clean up things you don't need anymore, like logins, agent jobs that are disabled that you don't actually need, any linked servers you don't need, things like that to get the instance ready for migration. Then you want to go and get the legacy databases ready for migration. And what you're trying to do here is make each of your databases smaller so they're easier to migrate. And so this is just a good time to do things you've been putting off to clean up these databases. So if you've got scratch tables full of copies of other tables that you used temporarily and never cleaned up, try to get rid of those and talk to the business about, hey, we've got 10 years worth of data in this table. Do we really need that anymore? And a lot of times they'll come back and say, oh, no, we don't need all that. You can get rid of all of it or just some of it. And so maybe you can delete it, or maybe you can archive it and move it to a different table or a different database. You also want to look really hard for unused and duplicate indexes and take the time to do a little bit of index maintenance. And then after you've done all this, you may have a lot of space in your data files. And if you have done things that has gotten rid of data that's not going to come back, you might consider the sacrilegious step of shrinking your data file, as a one-time thing. And of course, if you do that, when you want to go back in and do some index maintenance to get rid of the fragmentation that shrinking a data file causes. And then you definitely want to go in and reduce your VLF counts, your virtual log file counts, and then shrink your transaction log file as part of that. And if you have any extra transaction log files that got put in during an emergency, get rid of them. You only need one. And then finally, run dbcc check db before you get ready to do a migration. And if you find any kind of issues with corruption, try to correct those before you move forward with the migration. All right, there's a tool that you may not have heard of called the Microsoft Data Migration Assistant. And they just put out a new version about a week ago, actually. But what this is really useful for is you can point this at your legacy databases, and it'll go through and look for issues that might cause a problem when you upgrade to a newer version of SQL Server. And you can go all the way back to SQL Server 2005 for legacy, and then go all the way to SQL Server 2017 or Azure SQL Database as a destination. So you can run this, and it's a pretty quick scan, and it'll come back with a list of problems. And it also will come back with a list of possible ways you can leverage new features in the latest version of SQL Server. Of course, you have to be aware that they're heavily biased towards Azure SQL Database features. Microsoft really wants you to move everything to Azure SQL Database. So they'll point out things that you could do better in Azure SQL Database. And you can use this to find issues, and you can also use it to move just your schema or your schema and your data if you want to, although I actually think there's better ways of moving your data. So the tool has two different purposes. So the next thing I want to talk about is one thing you're going to have to do as moving from an old version of SQL Server to SQL Server 2017 is moving all your data. And there's various ways of doing that we'll get to in a few minutes here, but one of the things that's going to come into play on almost all of these is how quickly can you do a full database backup and a full database restore. So SQL Server has had native backup compression ever since SQL Server 2008 in Enterprise Edition, and then they added it to Standard Edition in 2008 R2. And usually native backup compression gives you a very noticeable improvement in how long it takes to do a backup and restore, and it makes your backup file smaller and puts less stress on your I/O subsystem. And another thing you can look into is doing what's called a striped backup. So instead of just running your backup to a single backup file, you have multiple files. And if you have the option of running these multiple files to different LUNs that have different physical storage behind them, you can sometimes get a huge increase in performance in how long it takes to do a backup and then a restore. And then another thing that a lot of, especially more junior DBAs, may have never heard of is you have some database backup tuning options that you can use. So you have buffer count and max transfer size and block size that you can use as options to your backup command that can make backups go a lot faster and even sometimes help with restores, but usually it helps more on the backup side. And then another thing you want to do always as you're going through this situation is back up to a null device to make sure you can figure out how quickly you can read from your data files and log file so you can find out how quick you could theoretically ever do a backup. And then you want to try backups to different locations to see how quickly you can write to where those backup files are going. So for example, it might be quicker to back up to local storage and then copy the backup file, or it might be quicker to back up directly to a remote file share. It just depends on your infrastructure. So we actually have a demo to talk about some of this stuff. All right, so what we got going here is I have about a 7 gigabyte database. I took AdventureWorks 2014 and made it a little bit bigger than it normally was. So then what we're going to do is just see how big is this database. You know, it's in a single data file. It's about 8 gigabytes in size. There's a little bit, it's closer to 7 actually. There's about 700 megs of free space, and the log file is not that big. So here's the first thing. Here's how you back up to a null device. So it's just backup database to disk equals null. And then what I'm going to do in this case is not use backup compression. So we're just going to read as quickly as we can from that data file. And if I go to the messages tab, you can see it's flying. And so it did it in about 1700 megabytes per second. And I'm just going to run that again and see if it's faster, since I just had to reboot my machine a few minutes ago. And then we'll see what happened here. So if we go to the bottom, you know, it did about 2200 almost megabytes per second. So that's about as fast as we can actually get this to go. And so the next thing I'm going to try is running this backup to a single file destination. So I'm going to run it to my L drive. And my database lives on my C drive on this workstation. So we're going to do this, and we go here. You know, it's not nearly as quick since we're having the overhead of actually writing the backup file instead of just throwing it away to a null device. So it's almost done here, and this is going to be the slowest backup we run. And so that's not super impressive there. If we ran it again, it would probably be a little bit quicker since it's cached in memory. And the next thing we're going to try is a striped backup to 2 different drives. So I have an R drive and a V drive that are both really fast M.2 SSDs that I have in my workstation here. So when I run this, this is going to go through and be noticeably faster. And when this finishes up, we'll see what the statistics are. But the idea here is don't just do your normal backup. Go in and run a few tests here. And that's actually not super fast, but it was faster than we did before. So 650 megabytes per second. So right, the next thing we're going to try is running that same striped backup to the same 2 drives, but now we're going to try using these options right here. So buffer count 2200, block size 64K, max transfer size 2 megabytes, and we'll try that and see if that makes any difference here. And you've got to play with these numbers. This is going to vary based on your storage and your data. And that's going quite a bit faster, so up to 1794 megabytes per second. So, and that was with backup compression right here. So just for as an experiment, let's try running that same backup without backup compression. So we'll say no compression and see if it's faster or not. And that seems like it's pretty fast. Let's just give it a couple seconds. So it's actually a little bit slower in this case. So again, try experiments like this with your larger databases until you get it figured out. Okay, this is the very fastest way that I can back up this database with my hardware and infrastructure. And then after all this, here's a query that you can run just to see how long these things have been taking. So if we run this, if my mouse will cooperate, then what we'll get is a history of our most recent full backups. And you can see the elapsed time and whether or not we were using backup compression and where it was going to. So this is just sort of a handy set of queries that you can use to figure this out. All right, so going back here, what we're going to do is go back to where we were and then move along. So the major migration steps that you want to go through are your architectural planning, where you're deciding are you going to go physical or virtual, and that may be out of your hands. And then you're going to go through and pick your hardware and storage to get the most performance and scalability for the least license costs. And then you go through, ideally, and build and patch and configure your new environment. And you can take as long as you need to do this if you're doing this properly. And you want to make sure you've got a set of scripts that you use and a checklist so that you're making sure that all your new servers are set up identically and they're all set up correctly and you're not missing any important steps. And I've done several Pluralsight courses where I talk about some of the important things you want to think about to make sure you don't miss. And then you want to go through and actually do some performance testing in your new environment to make sure everything's set up correctly and it's performing like you expect it to do. And after you've done that, then you go and get some backups of your current production environment and just restore them using any method you want into the new environment. And that's when you can go in and use Data Migration Assistant and another tool called Database Experimentation Assistant, which is basically distributed replay on steroids. And it's a tool that lets you capture a live production workload and then replay that workload in your new environment on your new version of SQL Server and see if it's going to perform as you expect and whether or not you're going to get any big performance regressions from things like the new cardinality estimator. And then you also are going to go through, you and your organization, and do any manual and or automated testing that you have available just to make sure that everything works from a functional point of view and that you're not going to have any surprises when you go live. And this whole part of it can take weeks or even months in some cases. And then finally, you're ready to do your final production migration. And there's several different ways of doing that, but my favorite is log shipping. And then after you do your final failover, there's some tasks you need to do in the new environment after you've failed over from the old version of SQL Server to the new version of SQL Server. So production migration methods that are available, you've got upgrade in place, which is really a bad idea, even though it's fully supported. You can attach and detach your databases, which is also a bad idea, but people will sometimes do it because they have no other choice. A much safer method is backup and restore of all your databases. And then you can use the Microsoft Database Migration Assistant to actually migrate your data. But then the better ways of doing it, in my opinion, are using log shipping or using database mirroring. And then we'll talk about the post-migration tasks. So upgrade in place, if you do that, you don't have to worry about migration because all you're doing is running setup on your existing SQL Server instance on your existing hardware. So the data is not going anywhere. But there's a lot more risk here. And there's definitely going to be some downtime because the time it takes to run the setup program, plus you're probably going to have to at least reboot the OS after you install the new version of SQL Server on top of the old one. And again, this is fully supported by Microsoft, but there's just a lot of downsides. And some of the key downsides is that you don't really have any opportunity to properly test your new environment because all you're doing is running setup and praying that it works. And doing this encourages your organization to reuse your old hardware and storage, which might be quite a bit slower than what you can currently get. It also encourages you to stay on your current version of Windows Server. And it's just a lot more stressful for you and the organization. You're just hoping that everything works. And if it doesn't work, you're going to have a long weekend trying to recover in most cases. But there's some cases where this is the only solution because you just don't have the budget or the infrastructure to do it some other better way. And if that's the case, you want to make sure that the business is fully aware of all the risk and downside and try to talk them out of it. Don't just go along without a fight. So the next method is detach and attach all your databases in each instance and then move them. And if you're going to do this, make sure you're logged in as SA rather than as your own Windows login, for example, so you don't have any file permission issues. And then you're going to have to copy the files to the new location, probably on the new server. And the downtime is going to be proportional to how big all these database files are and how quick your network is. And then you attach your databases to the new instance, and there's a tiny risk that the attach operation will fail. It's very rare, but it can happen. And you want to make sure you use T-SQL for the attach and have it all scripted out instead of trying to navigate through the Management Studio GUI to do this. And again, there's much safer and much faster ways to migrate. And so I always try to avoid attach, detach. All right, backup, restore. This is the absolute safest method for migration. It's a lot less risky than attach, detach. Depending how you do this, there could be a long outage, but if you're smart about it, you can do a full backup restore and then a differential backup restore and log backup restores and get it so that your downtime can be pretty short. Not as short as log shipping or database mirroring, but still fairly short. And again, you want to go through and make sure you do the work to prepare your legacy databases to reduce their backup restore times. So getting rid of the unneeded data and your index fragmentation and shrinking your transaction log so it doesn't have to be zeroed out during the restore. Lots of little tricks you can do to shorten this window. All right, log shipping. This is my favorite. And with log shipping, it's really easy to configure. It doesn't require that you're on a domain or on the same domain. It doesn't require certificates or endpoints like database mirroring. It doesn't put any extra load on your old instance because you're running log backups anyways when you're in full recovery model. And then you're going to have a pretty short failover because all you have to do is run your jobs for log shipping to do your final log backups and then copy the backup files and restore them, and then restore each database with recovery and point all the applications at the new instance. And you can write T-SQL scripts ahead of time so that you can just run a couple scripts on each server and wait a minute or two. And in most cases, you'll be up on the new server if you've planned everything out and rehearsed it ahead of time. It's very easy and smooth. Now, database mirroring is a little bit more complicated to set up than log shipping. And you want to make sure if you're going to use database mirroring to migrate that you don't use a witness during the migration because you don't want any possibility of an unplanned failover. And you go and do all the work of creating the mirrored copy ahead of time. And your users and applications have no idea that you're doing all this work. And once you get mirroring set up, then you can run that way for as long as you need to until it's time to do the final failover. And then you do that final failover and it's just a one-way, one-time trip and you fail over from the old version to the new version, and then you go ahead and remove the mirroring session. And this can just be a few seconds for each database, so it's even quicker than log shipping, but it is a little bit more work to set up, and it does place a little bit more load on your legacy server. And if you're running Enterprise Edition, you want to take advantage of asynchronous mirroring so it's less of a load until just before the failover, and you switch briefly to synchronous and then you do your failover. So post-migration tasks that you want to take care of. Things you want to do, you want to run a full database backup on the new instance of all your user and system databases as soon as possible. And then you want to run dbcc check db on all your user and system databases. And then you want to run update statistics and just start off with SP update stats at first, and then you can go through and do update statistics with full scan on some of your key tables. And there's a new option in SQL Server 2016 that lets you set the scan rate and persist it. So you can do it at 100% for key tables, and then it'll remember that when you run SP update stats or any other kind of update statistics operation. So that's a really nice feature. Another thing you want to make sure to do, and I've been running to a lot of customers lately that have not done this, but go in and enable Query Store on your user databases once you migrate. So then you can start collecting some performance baselines, and it'll help you spot if you have any performance regressions. Then you can go in and freeze a good plan using Query Store. It's a very nice feature that a lot of people just seem to be afraid of or not be using. And then based on the testing that you did before you migrated, you probably want to go in and change your compatibility level to the latest compatibility level. But you need to be aware that's going to force it by default to use a new cardinality estimator, which sometimes causes big performance problems. But you should know this from your previous testing, whether that's going to be an issue for you or not. And then, since you're going to be on SQL Server 2017, hopefully, you want to turn on the automatic plan choice correction feature for each database. And that way it uses Query Store to spot when you have plan regressions, and it'll automatically go back to the last known good plan, and helps you avoid issues with parameter sniffing and bad statistics that get a bad plan in the cache, and suddenly performance gets a lot worse for no apparent reason. And then you just want to start monitoring how well the instance is running after you migrate. So I've got a bunch of additional resources that you can look up to find out more about this. So I did a whole blog series in August 2017 where I did a blog post every day talking about different upgrade and migration subjects. And then I have a number of Pluralsight courses, so upgrading and migrating to 2016, installing and configuring 2016, and then a whole course on configuring and troubleshooting log shipping. And then SQL Skills has an in-person class we teach on upgrading SQL Server. It's a 3-day class in the United States. So that's pretty much the end of the session. So if we have any questions, I have some time to take them now.
Okay, so as Glenn said, if you've got any, throw them through now. But Glenn, if we go back to slide around licensing, just about confirmation around the cost of an enterprise system running 2017 using 4 cores.
Okay. I think it was probably right here. Well, let me go back. This one. Okay. This is a 2-socket system. Okay. It's not 4 cores. It's, 2 sockets with a 4-core processor each. So this is 8 total licensed cores. So it's 57,000. So maybe that's where the confusion is coming from.
Okay, so perhaps. I think if you go back a couple of slides where you went what the cost was from a per core point of view, and so the question just confirming that would an enterprise 2017 system running 4 cores, would that cost 28,000?
Okay. Yeah, I think I had a slide that actually had the license cost per core right here. Yeah, that's correct. If you have 4 cores you have to license, then it's going to cost 28,000.
Okay, so I've got another one. Is there any link which can help me out to find the risks to mitigate or to migrate from SQL Server 2016 to 2016 Service Pack 1?
Not that I can think of. I mean, one of the links that I had in here was talking about all the new features that they introduced right here in SQL Server 2016. Those top 2 links, it just runs faster and know your limits. And then actually the top 3 links, all these talk about the new features. And I don't know, off the top of my head, I can't think of too many risks. I mean, most of what they introduced in Service Pack 1 was what they called programmability features. So things that you could only do previously in Enterprise Edition that you can do in Standard Edition now. But it wasn't like they were new features. They were just bringing them down to the Standard Edition SKU. And the only thing you want to be careful about there is that in some cases they put limits on the functionality for Standard Edition, so you can only use a certain number of cores or a certain amount of memory to run that feature. So that's the only thing I can think of from a risk perspective.
Okay. I can answer this one. Yes, the slides and the scripts will be available on the DBA Fundamentals archive site, and they will be available in a couple of days' time. So you will be able to go back, rewatch this recording, as well as download the slides. If we go to the next one. Okay, what is the best way to evaluate storage performance?
Well, there's several different ways of doing it. One thing I always like to do is run some synthetic benchmarks that are just quick and easy to run. So the first one is called Crystal Disk Mark, and it uses Microsoft Disk Speed under the covers, and it lets you test each one of your LUNs just in a few minutes to get an idea of its sequential performance and its random performance with different queue depths and different thread counts. So that's the very first thing I want to do. And then I might go in and run disk speed, which you can run from PowerShell or command prompt, and you have a lot more flexibility about what it does, and it also gives you latency information. So that's the first thing I like to do. And then the second thing I like to do is do some real world testing. So I'll do something like take a great big database and find out how quickly I can run a backup, or how quickly I can restore, or how quickly I can build a big index. Another thing I do is I'll do something like flush the buffer cache, in a test environment, and then purposely run a select query that forces you to read an entire table into memory to find out your real world sequential performance. So, a few tests like that will give you a pretty good idea how well your storage performs, after you've selected it and configured it. So.
Okay. This next question, it's a bit of a longer one, so I'll try and break it up. I've got concerns about migrating older databases that use different collations, i.e. Unicode is almost updated yearly. Does the migration wizard take this into account?
Well, the data migration assistant, I believe, looks for some issues along that line, but for collation question like that, really, you're probably, if you're going to run into any issues because of that, I think you would hopefully catch that during your testing in your new environment. So, there's some tools, and the migration assistant I think will catch some of that, but I wouldn't feel completely confident until I had done a full round of functional testing in the new environment to see if a collation issue is causing a problem or not. And of course, being in the United States, I'm kind of spoiled because usually we just use the default collation that comes, from SQL Server, but I understand that's a bigger issue in other parts of the world.
And would you think that a greenfield data migration might be better than a traditional migration? So I'm assuming, i.e., backup and restore.
Well, it doesn't really make any difference because, a backup restore, you're taking a backup of the legacy and restoring it in the new environment. And as part of that, it gets upgraded to the new file format, whether or not you change the compatibility level or not. And these other things you're doing, for instance, like log shipping or mirroring, are doing the same thing because you're taking a backup of the old and restoring in the new environment, and it gets upgraded the same way. And so there's really no difference there.
Okay. So we go back to the licensing question as a follow-up. So if we're using 2 cores in a virtualized environment, are we still going to be charged for 4 cores?
Well, that depends, because if you're just going in and licensing individual VMs, you'd have to pay for each core, and you're supposed to pay for a minimum of 4. And so if you're only using 2, they would want you to pay for 4. But if you have enough licenses for the entire host and you have software assurance on top of that, then you can go in and create as many VMs as you want with as many cores as you want. And so you could get away with just having 2, and they wouldn't try to make you pay for 4. So that's how that works with virtualization.
Okay. Last question. What hiccup have you come across which caused you the most headache when migrating to 2017?
Well, the biggest issue that people still run into is issues with the new cardinality estimator that they introduced all the way back in SQL 2014. And most queries run as well or better on the new cardinality estimator, but some larger, more complex queries still have pretty severe performance issues. So again, hopefully you will run into those during your testing and not be surprised. And the nice thing is with 2016 and 2017, you have more knobs to turn. You can have things like database scope configuration, so you can go in and turn on or off that cardinality estimator at the database level. Previously, you had to do it at the instance level or the individual query level. And now you have more options to handle that issue. But that's the biggest problem that I see people running into is a cardinality estimator.
Okay. Well, if we've got no further questions, I'd like to thank Glenn for his time in presenting to us today on migrating to SQL Server 2017. I'd like to thank all of you attendees for coming along and being part of this month's session. So, as mentioned, this is being recorded and will be available on the DBA Fundamentals archive site. Make sure that you go there, review this. You'll be able to download Glenn's slides as well as the backup scripts that he took you through. Also, make sure that you register for the other DBA fundamental sessions, both in North American time zone and once again, the Down Under time zone next month. We are running a week later next month, but we will still be on. So I look forward to seeing you all again in a month's time. Thank you.